In Chapter 2, we are looking at some historical counting systems. The first system we have, one of the oldest system, is the tally system. We know how tally works. We use tally all the time. We even still use it today. So, for example, what number do the tally bars below represent? We know that we typically using 4 bars with the 1 slash down for 5. So in this case, you have 3 5s and a 2. So this picture here represents 17 in tally system, right? So same thing here. Okay, if you want to write 12, it will be a 5 plus 5 and a 2. Now, decimal system. This is something we're familiar with, right? So we have our decimals. We have our ones, tens, hundreds, thousands, 10,000, 100,000s. Okay, that's something that we used to. So here it is. Okay, so one of the things that we need to be familiar with, we need to know all our place values, like in example 2.3. So any of these number was given to you that you need to know. Okay, if you're not sure about it, once again refer back to this chart up there. Now, expanded notation. So to write expanded notation is to tear your number apart into placements. So for example, 7,256 is 7 1,000s, 2 100s, 5 10s, and 6 1s. So the way you write it is exactly like this. So instead of saying 7 times 1,000, another way to write it would be saying 7 times 10 to the third power, and then 2 times 10 to the second power. Because 10 to the second power is 100. So you have 7 in the thousands place, 2 in the hundreds place, 5 in the 10 place, and 6 in the 1 place. Okay, here's another additional example, 100,653. So again, make sure you have zeros to hold their places, and then you have 600s, 5 10s, and 3 1s. Now, looking back some of the older civilizations, like in the Mayans. So Mayans numeral system, if you take a look, okay, so it's positional. So what happened? Well, first of all, this you kind of get yourself familiar with their basic writing for the number system. So you have this shell eye looking thing that's 0, and 1 dot, 2 dot, 3 dot, 4 dot. The minute you get to the 5th dot is the bar, and then you have a bar plus 1 dot becomes 6. So you kind of add them, right? And add 2 is 7, so on and so forth. Okay, and up to 19. So they go 0 to 19. Then once you get up to, you fill all your pictures to 19, then you move on to the next placement, just like us. Okay, so for us is every 10. You go to our system is base 10. For Mayans, it will be base 20. Okay, so if you take a look at this, that's what base 20 means. So they have 3 positions. On the very bottom, that's 20 to the 0 power, which is just ones. So the very bottom one is like our ones. And the second one, instead of 10 and hundreds, it's 20s and 400s. So it's 20 to the first power, 20 to the second power. Versus ours is ones, 10s, and hundreds. Think of ours as the middle number. It will be 10 to the second power and 10 to the third power. I mean, 10 to the first power and 10 to the second power. But instead of 10, they have base 20. So Mayan is base 20 system. So when you see a picture like this, how is it translating to our number? Well, so the bottom is 1. So you see that this symbol right here means 7. Go back to the reference back to this chart here. So a bar with 2 dots on it, that's 7. So since this is in the ones place, so it's 7 times 1. Now, next one, you have 3 bars. Each bar is 5, so you have 15. Now, this is in the second placement. And then the second placement is, each one represents 20, so 15 times 20 is 300. Last but not least, on the very top, that tier represents 400th place. Then you have a 12 in here. So 12 times 400 is 4,800. If you add up all the numbers, you get 5,107. And that's our number. So this Mayan symbol here represents 5,107 in our number. Okay, so more practice here. So if you look from top, you have 7 in the 400th place, a 5 in the 20s, and a 0 on the bottom. So if you multiply and add them all up, it's 2,900. Okay. So here it is. Okay, it's just more examples. 0 on the very top, and then you have 400. Okay, then 9 in the 400th place, 6 in the 20th place, and then 4 in the end. So you add them up, 3,724. Now, if you were going to do addition, okay, addition with the Mayans number. So say you have these two things, you try to add them up. So what do we have? Let's look at our first step, okay? So we're going to add, well, if we're going to add them up, let's see what happens. So if you add them up, basically you combine both figures together. So what I did in the step one is combine all the figures together and then see what I have. Okay, and then notice, okay, on the bottom, I'm fine. I have a 7 and a 0. Okay, that's, just 7. And then in the middle, right, however, in the middle, you have what, 4 bars. Now remember, every 20, you go on to the next placement. So that 4 bars, each bar is 5, so that's 20. So if you go to the second step, if you look, that 4 bar disappears because every 20 will give you 1. So by placing one extra dot onto the very top row, that dot now is represent like the next placement, right? And then it's just like our, if we add number in our system, it's like a carryover. Basically, it's carrying over to the top level. Okay, and the same thing with the third step. If you look at the third step, if you add them up, you see like I have 5 dots here. These 5 dots become a bar, and again, now once those 5 dots become a bar, I have 4 bars again. Every 4 bars, we move on to the next one. So you have one more. We increase another dot onto the very top system, top placement. So our final answer look like this: a dot on the very top row, and then you have a 7 on the very bottom row. And remember, the very bottom row is 1. The one above that is 20 to the first power. The one above to that is 20 to the second power. The one on the very top with only 1 dot on it is 20 to the third power. So 20 to the first, 20 to the second, 20 to the third. So we have 1 dot in 20 to the third and plus the 7. So the answer is 8,007 in base 10. Base 10 means our system. Now, what are some of the bases? Now, we look at the Mayans. The Mayan base is base 20. Our number is base 10. But we can, we can use the same idea to look at any other system. There might be a different system, different base system. Okay? So, for example, if you have 5 system here, okay, 20. So the question is 23 5. How do we change it? If 23 is written in a country or in a culture that's or in an ancient time, but their system is base 5. Now, how is that translate to how much it is? How much value is there in our number? Okay, in other words, we're converting 23 to how much is that? If there was money, okay, what's 23.5 in our dollars today? So the easiest way to convert that is, well, since it's base 5, so we know the first number is always 1, and the second column is 5 to the first power, 5 to the second, 5 to the third, so on and so forth. So since this one only had 2 numbers, so 23. 3 is in the 1s, 2 is in the 5s. So we have 2 5s and 3 1s. So when you add them up, you get 13. So 23 5 is the same as 13 10s. Let's look at example 2. Part B. Same idea. You have 412, but the 2 is in the 1s place, 1 is in the 5 place, and 4 is in the 5 to the second place. So if you multiply that out, 4 times 25 plus 1 times 5 plus 2 times 1 give you 107. So it doesn't matter how big the number is, you just continue that chart, start with the 1, and then 5 to the first power, 5 to the second, 5 to the third, 5 to the fourth. Then once you find each number to where the placement is supposed to go, you just multiply them and you add up the whole thing. Then the sum will be the number you're looking for in base 10. And we look at other bases as well. Okay, so this first example here is your base 2. So we do exactly the same thing like base 5, but except the top, instead of 5 to the second, 5 to the third, 5 to the fourth power, it's 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. Then you do the same thing after you place all your numbers into each corresponding space. You multiply and you add. So in this case, for A, the answer is 27. Now, if you look at 103, if it's base 8, then same thing. We do A to the first power and A to the second power. We only need 3 boxes because the end number is 103. Then once you do the same thing, you multiply, you will get what you need. Okay, and 16 is the same thing. You only need two boxes. So remember, the first box is always 1, and the second one is the first power of whatever the base is, in this case, 16. Now, do we know how to go backwards? So if you want to go backwards, okay, so let's see what happens. If you want to write our number to other base system, so we want to try to write 12, that's our number, to what's 12 in number that's in base 5? Well, to go backwards, instead of multiply, you're going to divide. So you're going to divide by 5s. That's what it is. So if you take 12 divided by 5, you get 2, and then left with 2. Now, that 2 is going to be our first numbers, first answer. Now, whatever the leftover, the remainder on the very bottom, you're going to start a new division problem with that number, and then we're going to divide by, well, why do we divide by 1? Because if you look at the chart here on the side, how do I know what's the first number I'm going to divide by? Well, if this is a base 5, okay, pretend we're doing the problem from the previous section, then your box will be 1, 5 to the first, 5 to the second. But notice 5 to the second is 25. Our number is only 12. You cannot divide by 25. That's why we start with 5. So you divide by the 5 and divide by the 1. You just divide it down, and then so when you take 2 divided by 1, you get 2 left with 0. So the top quotients, 2 and 2, that's our answer. So 12 is 22 in base 5. Let's look at this one more time. Same thing, if you want to change to base 8, well, if you look at the boxes, 1, 8 to the 1, 8 to the 2. Now, 8 to the second power is 64. Then that number is already bigger than 35, so we're not going to use that. So we do the same thing. We do 35 divided by 8. We have a 4. That's partially our answer. You're left with a 3. Then you take the 3 and divide again by 1 by the next number down, which is 1. So you get a 3. And when you're done, so the answer is 43. Okay? So this next question right here, okay, it's the same thing, okay, if you want to try to do the base 4. Now, it's hard to fit everything in the box, so I'm writing this down. 4 to the 8th power is the biggest number you will ever get, which is 65,536. So if you want to change it to base 4, you divide by 4 to the 8th power first. You get a 1. Then you divide by 4 to the 7th. If you look, I keep taking the remainder, divide by the next power, which is 4 to the 7, 4 to the 6, 4 to the 5, 4 to the 4. If you look what I'm dividing all the way down to 4 to the second, 4, and then eventually 1. And then whatever the quotient you get, it's going to be the answer. Now, even there's a whole bunch of zeros, and you still have to count those zeros, they do fit the placement. Then if you have those, then that'll be a whole answer. Remember, you have to remember the zeros. You have to divide every placement. Okay, same thing here with the 7th. So 4,509. The biggest number you can do is 7 to the 4th power because it's 2,000 something. 2,401. If you do 7 to the 5th power, you go over 4,000, and we can divide that number. So we divide by 7 to the 4th, 7 to the 3rd, 7 to the 2nd, which is 49. Divide by 7 to the 1st, which is 7, and then divide by 1. And every time you divide, whatever the remainder you have, you divide again. Whatever the remainder you have, you divide again till you get to the very last one, 0. Then whatever is in the quotient, 16101, that's your final answer. And that's how we convert from our number to any of the other bases. Okay, so addition and subtraction, it's the same thing, okay, but you have to think in terms of converting at the same time. So if you look at like the first question here, okay, if we want to add 110 and plus 11, now it's not our number adding, we know how to do that, but for theirs, if you look, if you take the 0 plus 1 is 1, but 1 plus 1 is, why does it become 0? Where I'm adding the second part. Well, because 1 plus 1 is 2, but remember this is what, base 2. That means for every 2 you see, you don't write a 2, you carry over 1 more. Just like we don't write, when we have a 5 plus 5, we don't write 10. We write a 0 and with a 1 carry over. So in this case, whenever you have anything that's 2 or above, you're going to carry over. So if you keep carrying over, then we get 1001 in base 2. Same thing here. If you look at B, because look, it says on the side here, I roll it right here. Every time we have a 2, it become a 10 twos because you go on, you carry over to what you increase 1. You count it as 1 over, just like how the Mayan system is. Every time you collect 4 or 5s, and then you wipe it out, become a 0, and then you move 1. You add a 1 dot to the next next placement. Okay, same thing with the fives. If you look at the five system, it's exactly the same thing.